Today's video will be on area. So our learning goals for today, by the end of the lesson you'll be able to calculate the area of a rectangle, you'll be able to calculate the area of a triangle, and you'll be able to calculate the area of composite shapes. You'll also be able to convert between different areas of measurement. Okay, so the first thing we're going to do is converting between metric units for area. So we have done converting between metric units, but for area it's slightly different. So we're going to stick to the same basic one. So we'll do kilometers, meters, centimeters, and millimeters. So if we're going from kilometers to meters, because it's area, it's going to be squared. So if we're going from kilometers squared to meters squared, what we'd normally do to go from kilometers to meters is times by 1,000, but because it's squared, it's timesing by 1,000 squared, which means 1,000 times 1,000, which is 1,000,000. Next, to go from meters squared to centimeters squared, normally you times by 100, but now it's 100 squared, so that's equal to 100 times 100, which is, what's that, 10,000. And to go from centimeters to meters, normally you times by 10, but it's 10 squared, so that's equal to 10 times 10, which is 100. So you'd multiply, by each of those each time. So doing the opposite, going from millimeters to centimeters, normally you divide by 10, but now we're dividing by 10 squared, which is the same as dividing by 100. Centimeters to meters, normally you divide by 100, that's 1,000, normally you divide by 100, but because it's squared, it's divided by 100 squared, which is dividing by 100 times 100. And to go from meters to kilometers, normally you divide by 1,000, but because obviously it's meters squared to kilometers squared, you're dividing by 1,000 squared, which is dividing by 1,000 times 1,000. So that's what we do to convert between our metric units there. Okay, so our worked examples, we're going to convert these area measurements to the units shown in the brackets. So for A, we've got 0.248 meters squared, and we're converting that to centimeters. So normally we would times that by 100, but because it's units squared, it's going to be 100 times 100, so we're timesing that by 10,000. So we're just moving our decimal place 4 spots, so that would be, there we go, so 2,480 centimeters squared. So for B, we've got 3,100 millimeters squared, and we're converting to centimeters squared. So normally we divide, normally we times that, divide that. Normally we divide that by 10, but because it's units squared, we're going to divide it by 100. So move our decimal place 2 spots, which leaves us with 31 centimeters squared. Okay, so moving on to area now, the first thing we're going to look at is area of a square. So our formula for area of a square is area equals length times length, which we can also write as area equals length squared. So in this instance here, we have a square, so really each of the sides should be marked showing they're the same length, and one side is given as 6. We don't know the units, just 6. So our area, as we know, is length squared. Fill in what we know, so that is 6 squared. 6 times 6 is 36. Now we don't know the units, so what you would have to do is write units squared and just leave it like that. So that would be our answer for area of a square. Okay, our second shape is area of a rectangle. So the area of a rectangle is area equals length times width. So area equals length times width. For our worked example here, again, this should be marked each of the sides, but they are right angles, so we can assume that they're all the same length. The corresponding sides are the same length, each parallel side. So length times width, so we're going to do 6 times 2, and that's 12, and we're given the units this time, so 12 centimeters squared. Don't forget to write the centimeters squared because we're dealing with area. Okay, so we've got a triangle here. So area of a triangle is the half the base times the height. Now the height will be the value next to this kind of dotted line at a right angle. So whenever you see that, you know that's the height. So for our work example, calculate the area of the triangle below. Always start with our formula. So area equals a half base times height. So that's a half times our base, which was 13, times our height, which was 7. In our calculator, 1/2, which is 0.5, times 13 times 7. And that will give us an answer of 45.5 meters squared. And that's area of a triangle. Okay, so area of composite shapes. So composite shapes are shapes that are made up by multiple basic shapes. So we can find the area of composite shapes by either adding or subtracting the area of more basic shapes. So for instance, if we look at A here, you can see we've kind of got like a rectangle. So if we were to fill in this area here, we would have a rectangle. But the shape that it actually wants us to find is outlined there in blue. So it's that rectangle, but it's actually had a triangle cut out of it. Because if you look here, this is our triangle. So we can actually use the formula for area of a rectangle and area of triangle to actually find the area of that composite shape. So our total area, which is that blue bit there, is going to be the area of a rectangle. So the area of a rectangle, and from that area of a rectangle, we have to take away the area of the triangle. So I'm going to fill that in. So area of a rectangle is length times width, and the area of a triangle is a half base times height. So now I can fill that in with my values. So area of a rectangle is length times width, which is 10 times 6 times 6. Subtract the area of our triangle, which is a half. Our base, which is also 10, so a half times 10 times our height, which is 4. So using our order of operations, obviously we do multiplication and division first before we do subtraction. So that's going to be 60. Take 20, a half times 10 is 5, 5 times 4 is 20, so 60 take 20, which will leave us with 40 meters squared. So what I did there, just to repeat myself, is I found the area of that rectangle, which is 10 times 6, 60 meters, and then I've subtracted the area of that triangle away from it, because that's the bit that's cut out, and that's just left me with the remaining shape, which is 40 meters squared. Okay, so I'm going to clear the screen so I can do the second one. So for our second one, if we look at this, it's a more square kind of shape. So there's a few ways you could work this one out. The way that I would do it is I would put an imaginary dot down here, and I'd work out the area of this shape, which I'd call A, plus the area of this shape, which would be B, and I'll add those together to get the total area. So you could divide this up multiple ways, but this to me is the easiest. So the total area equals the area of A, which is a square now, plus the area of B, which is a rectangle. So the area of the square, which is A, which is length cubed, plus the area of a rectangle, which is length times width. Now, for this area A, which is this shape here, my side length is 3 millimeters, so it's 3 millimeters squared, plus the area of my second shape, which is length times width, which is 1 millimeter times 1.2 millimeters, 0.2. Then using order of operations, obviously I'm going to solve that. So 3 squared is 3 times 3, which is 9, plus 1 times 1.2, which is obviously just 1.2. Add those together, so that's 10.2 millimeters squared would be my total area for that composite shape. So there we go. And that's the end of this video. Any questions at all, please come and see me in class.